If you're losing marks on binomial expansion in paper 3, it's probably not because the topic is hard. It's because you're missing these three question types. In this video, I'll show you the exact patterns examiners love to test in Cambridge 9709. And once you understand these, binomial expansion becomes one of the easiest scoring topics. Let's get straight into it. I'm going to first look at the binomial expansion formula for paper 3. It's given right here. 1 plus x to the power of n. Now this differs from the paper 1 binomial expansion formula in that n could be any real number. So n belongs to real numbers. What that means is earlier last year when we did paper 1, n had to be a whole number and it had to be positive. This time it could be a fraction, it could be negative or positive. So n could be any real number. The first term has to be 1, only then the expansion formula works. If it is not 1, we will have to make it 1. And finally, the second term, it's represented as x, but it could be any variation of that. You have to keep its sign in mind as well. In this case, it's positive. It could be negative as well. And the peculiar feature about the second term is that its modulus is less than 1. So what that means is for this expansion formula to work, x's value has to be a positive or a negative fraction, or it has to be 0. Right. Now this formula, 1 plus x to the power of n, is given in our formula sheet MF19. And what it says is if you expand this, it's a expansion that doesn't end, which is why we have the dots here at the end. And it is 1 plus nx. Then you start decreasing n, so n into n minus 1, and you start increasing the power of x and divide by the factorial of the power. That's basically what the formula is. So this is something you need to note down and learn up. It's there in your MF19, but it's always helpful to know it by heart. First example we're going to do is a straightforward example. It asks us to expand cube root of 1 plus 6x in ascending powers of x, and we have to expand it up to the x cubed term, and we have to simplify the coefficients. This is a 4-marker question. Right, so let's get right down to it. 1 plus 6x to the power of, so cube root can be represented as 1/3, as a power of 1/3. Right, so if you look here, this binomial expression is already in the standard form that we require. The first term is 1, the second term is 6x, and the power is a real number, 1/3. Okay, so we can use the formula directly. The formula says, okay, and I'm just, for the sake of this first question, I'm going to just identify the parts here. In our formula, x is the first term. In this case, it is 6x. N is 1 by 3. And so the formula says it should be 1 plus nx plus n minus 1, x squared by x, sorry, not x, but 2 factorial and so on. I'm going to apply that in this particular case. So 1 plus n here is 1/3, x is 6x, x represent, in the formula, x represents the second term, plus 1/3, 1/3 minus 1, 6x the whole squared by 2 factorial, and we have to go up to the x cubed term. We've reached the x squared term, so that is plus 1/3, 1/3 minus 1, 1/3 minus 2, 6x the whole cubed by 3 factorial. You can now simplify this to, just put it into your calculator, don't bother to do it manually. So 1 plus 2x minus 4x squared, that's the third term, and the last term is plus 40 by 3 x cubed. So we've done what the question has asked us, which is expand up to the x cubed term, and we've simplified the coefficient. So this is our answer. Now part B here says state the set of values for x for which the expansion is valid. This is a 1 marker. So all you have to do is take the second term of the binomial expression, that is 6x. So the modulus of 6x has to be less than 1. And we simplify this by taking the 6 to the other side. So modulus of x is less than 1 by 6. And that's the answer for the part B of this question. Here's the second type of question you're likely to see. It says find the coefficient of x cubed in the expansion of 3 minus x the whole into 1 plus 3x to the power of 1/3 in ascending powers of x. And this is a 4-marker question. So here we have a binomial expansion which we have to do, 1 plus 3x to the power of 1 by 3, and that expansion has to be multiplied by 3 minus x. So let's do the expansion first. It's already in the standard form which we require it to be in order to use our binomial expansion formula from your MF 19. So the formula is 1 plus nx plus n minus 1 x squared by 2 factorial, where x is represents the second term of the binomial expression. Okay, so applying that, 1 plus n is 1/3, x is 3x, plus 1/3, 1/3 minus 1, 3x the whole squared by 2 factorial. And we have to go up to the x cubed term, so I'm going to continue, plus 1/3, 1/3 minus 1, 1/3 minus 2, 3x the whole cubed by 3 factorial. Simplifying this, we get 1 plus x, remember we're just putting it into our calculators, minus x squared plus 5 by 3 x cubed. Now we want to combine 3 minus x by multiplying it with 1 plus 3x's expansion. So that is 3 minus x into 1 plus x minus x squared plus 5 by 3 x cubed, and so on. We haven't expanded it further. Right, so we want to find the coefficient of x cubed. So you have to multiply 3 by every single term in the second expression, and then you have to multiply minus x by every single term in the second expression, just like normal algebra. But we're only interested in the x cubed term. So which multiplication gives us an x cubed term? I'm just going to list out the x cubed terms. So if I take 3 and multiply it into 5 by 3 x cubed, I have an x cubed term. So 3 into 5 by 3 x cubed, and minus x, this minus x here, if I multiply it into minus x squared, I get an x cubed term. So minus and minus gives me plus, and that's x cubed. No other combination that's multiplied will give me x cubed. So these are the x cubed terms. We can just factorize the x cubed out, and I get 5 plus 1, which is 6x cubed, right? And then they said find the coefficient of x cubed. So the coefficient is 6, and that's your answer. Finally, here's the third type of binomial expansion you really must learn to do. It says expand 4 divided by square root of 4 minus 3x in ascending powers of x up to and including the x squared term, and it's a 4-marker question. Okay, so let me just write down what they've given to us. It's 4 divided by root of 4 minus 3x. So first thing we want to do here is not have a denominator. So we bring the 4 minus 3x whole root up to the numerator. So it becomes 4 minus 3x to the power of negative half, because we're bringing a root up to the numerator. Okay, now the other thing you have to note after bringing the denominator up is that this binomial expression is not of our standard form, which has to be 1 plus x to the power of n. So we have to make the first term 1. So what do? Keep the 4 as it is. That's this 4. And the 4 minus 3x, we're going to factorize within brackets. So I'm taking the 4 out as a common factor. So what I'm left with is 1 minus 3 by 4x, and the whole thing to the power of negative half. This is a super important step. Please understand it and learn it up. Now what you want to do is keep this 4 as it is, and the minus half power has to be applied to the 4. So 4 to the power of minus half, and it has to be applied to the binomial expression as well. Right, so now this simplifies to 4 into 4 to the power of minus half is 1 by root 4. And then you have your binomial expression, which is now in the standard form of 1 minus 3 by 4 to the power of x to the power of minus half. Now we just simplify this. So it is 4 by root of 4, which is 2. And then expand 1 minus 3 by 4 to the power of x. So that's 1 plus n, which is negative half, x, which is negative 3 by 4x. And we are expanding up to the x squared term right there. So plus negative half minus 1, negative 3 by 4 x the whole square by 2 factorial. Trying this further, we get 4 by 2 is 2, and then using our calculator, just simplify the inside of the bracket. So that's 1 plus 3 by 8x plus 27 by 128 x squared. And then if you like, you can just multiply the 2 or expand here. So that's 2 plus 3 by 4 x plus 27 by 64 x squared. And that's your answer. If you found this helpful, make sure to like and subscribe for more A-level math content. And don't forget to check out the short on the 2 binomial mistakes, link in the description. I'll see you in the next one.